Hello everyone. Today we'll work on leetcode problem 1439. Find the kth smallest sum of a matrix with sorted rows. So this problem says we are given a matrix. Its size is m by n. And it has rows already sorted in non-decreasing order. So for example, this row is 1, 3, 11, and the second row is 2, 4, 6. All of the numbers are not decreasing. And we're going to pick one element from each row and form an array. And this array will have a sum. And we're required to return the kth smallest array sum among all possible arrays. So this problem, the data size is not so large, right? The k is a minimum of 200 and n to the m's. Although n to the m's is very large, but it has a minimum at 200. So we have at most 200 levels. And if we, for example, we know that the smallest one is, we already know the smallest one, right? The smallest one is just the sum of all the first element, right? Then we can iterate every choice. So for every possible choice, we just move this index one step later in this matrix, right? And actually, it's similar to a BFS search. And we have 40 levels. And each level, at most, there is 40 numbers. We have, yeah. And if we found a number that we pump up all the numbers we have visited, and if we count the number and the number equals 200, then we will stop, right? So we just use like priority queue, big numbers at the top, right? We small numbers at the top. So we maintain a priority queue to store the sum and which index it is from. Okay, then each time pump the queue top and update queue. And that is the algorithm we were going to use. And let's write the code. So m equals the size of the matrix, n equals the size of the first row, and we will need some vector to remember to remember the which index in each row this sum is coming from. So this means vi means sum is from row I and column vi. Okay, and we define this sum and we calculate it. First, it's actually auto row in matrix sum plus equal to row 0, right? And we don't need to change v because we have already initiated to all 0, because this number sum initially is the sum of all the first number in each row. So v is also valid. Then we define the priority queue. Let's use some short notation. A pair of int and a vector equals pair of int and a vector. Okay? So it's PIV, and we use vector for this queue. And we need to have this function here. to indicate its smaller numbers at the top. It's by default, this is less. So now it's greater, so it means smaller number at the top. And we put those, we put this sum and v into this queue, okay? And we actually need another set of PIV. This all the index combinations we have visited, we have used, or maybe we have used. So st will insert v, and while q is not empty, and we define a count. So this count should be less than k. We do the following things. If count is k, it means we have reached the kth element. So auto f is the top of this queue, and q pop. And we update sum equals f first, and then we update this queue for int I equals 0, I less than m plus I. We have a next vector, which is initially f second. So the next index will be I and j. So j will be next I plus 1, right? If j is less than n, then we can update it, right? If j is less than n, then we first put j into next. And second, we will check if j has been visited or not, if next has been visited or not. So st count next. If this is 0, it means it's not been visited. Of course, we need to add it into this visited after we've done the process. And q will push the sum. What is the sum? Sum is the previous sum less matrix I j minus 1 plus I j. Okay, this is the new sum, and next is the new index. And at the end, we will just return the q top first. Oh, well, do not forget to increase count by 1 at the end. And I think that's it. Let's see. So I think we have put some wrong. Oh yeah, this is. We need to insert. This is not PIV. This is a vector, right? It's just for the index. We have a wrong number. Let's see. Seems case 2 and case 3. Case 2 is correct, but case 1 is wrong, and case 3 is wrong. Let's see what's happening. So let's read the code again. So first we initialize m and n, and we initialize the v. V is the index at the beginning. So the size is m, and also all the index are 0. And we calculate sum. And we define this priority q. Then we have defined this. St is all the numbers we have visited. Then we push this sum into this queue. And we also push v into st. Then we initialize count to 0. And while q is not empty and count is less than k, we get the first element in the queue. And sum is just the first of this element. So it is this value. This should be right. And then we update this queue. So for each row, and we first let next to be a copy of f second. Then we have j equals next I plus 1. And if we have j less than n, the max number of the column, then we can have next I equals j. And if we have not visited j, then we can push it into our queue. How do we push it? The number is the sum minus ith row and j minus 1. J minus 1 is actually the original value of next I. Then we plus ith row j's column, the new number. Then it's next. And we put next into this visited set. And here is count plus plus. And we will return q top first. Q top first is, we should not return q top first actually. We need return sum, right? Because each time sum is updated by this number. Yeah, I think this is correct, and let's submit. Okay, it passed. And I think that's it for this problem. Thank you for watching. See you next time.